Now we are discussing about binary symmetric channel. Okay, how this channel is there. Here, in previous class we discussed symmetric or uniform channel. Here the condition probabilities in each row, it will be same condition probability. Whatever in the first row, same thing we repeated in the second row also. It's not in sequence. Okay, that is called as symmetric or uniform channel. Here, just remember its capacity is log S minus H. What is log S here? Log S is, okay, this log S is, see here, we know that C is equal to maximum of I of A comma B, maximum of H comma B minus H. Here we know that I of A comma B is equal to H of B minus H of B divided by A. Here we already proved this one, H of B divided by A is equal to H. Here what is H here? H is equal to this term, where I'll show you here. This term is H of B divided by A. Okay, this term becomes 1. Then H is equal to summation of j equal to 1 to S Pj log of 1 divided by Pj. Pj log of 1 divided by Pj. Summation of j equal to 1 to S Pj log of 1 divided by Pj. That is H. Okay, that is H of B divided by A. Then here H is constant here, that's why I taken outside. Then maximum of H of B. If we have the equiprobable, okay, if we have the received symbols become equiprobable, whatever the output, B stands for output symbol, A is input symbol. Whatever the symbols received at the output side, at the receiver, it would consist of equiprobable, equal probability. Then H of B maximum is equal to maximum of H of B, that is equal to log of S. Therefore, C is equal to log of S minus H. Now, second channel is binary symmetric channel. Binary symmetric channel. Here we know that BSC is one of the most commonly and widely used channels, whose channel diagram is, the channel diagram of the binary symmetric channel is, okay, x1 and x2. For x1 its binary value is 0, for x2 its binary value is 1, and its probability is W and its probability is W bar. Okay, then x1 to y1, x1 to y1. Here y1 take the 0 value, y2 take the 1 value. Okay, its condition of probability when x1 to y1 p bar, that is 1 minus p, just remember. Then x1 to y2, the condition probability is p of y2 divided by x1. Okay, then x2 to y1, when we send the input signal 1, okay, if we receive the output as 0, then p of y1 divided by x2, that is equal to p, condition probability. If we send signal 1 and we received signal 1, then the condition probability is p bar. Okay, just remember here p bar is equal to 1 minus p. P bar is equal to 1 minus p. Here equal p plus p equal to 1. P is equal to 1 minus p. Here we know that the sum of the probabilities is equal to 1. Here we have two symbols, right? Here we have two symbols. Okay, one condition probability is p, one more is p bar. The sum of condition probability is equal to 1. Okay, that is equal to 1 here. P is equal to what? Sorry, p bar is equal to 1 minus p. Just remember this. This is very important. Okay, next. Here P of x1 is equal to, probability of x1 symbol is W, already mentioned here. P of x2 is equal to 1 minus W. That is called as WR here. Okay, W plus WR equal to 1. Then W bar equal to 1 minus W. Okay, P equal to probability of error, probability of reception of 1 when 0 is transmitted, probability of reception of 0 when 1 is transmitted. P, see here, where is P? This is the probability of error. This P is probability of error. Here we send the signal 0. What do we get here? Output as 1. That's why probability of reception of 1 when 0 is transmitted. Similarly, 1 transmitted we get 0. That is called, see here, the condition probability, that is P. And you get that means probability of reception of 0 when 1 is transmitted. Okay. Note that in a BSC, the symbol x1 is encoded as 0 and x2 as 1. Already mentioned here. x1 symbol mentioned as 0, the x2 symbol as 1. Encoded as 0 and 1. The channel matrix of BSC can be written looking at the channel diagram of figure. Here, row wise x1, x2, y1, y2, right? x1 and y1. When we send the x1, we get the y1. Then what is the condition probability? P of y1 divided by x1. x1 and y2. P of y2 divided by x1. P of y1 divided by x2. P of y2 divided by x2. There, we mentioned, they declared the condition probability value here. P bar and P. x1, y1. That means P of y1 divided by x1 is P bar. P of y2 divided by x1, P. P of y1 divided by x2, P. P of y2 divided by x2, P bar. That's it. Okay. Now, the matrix of 3.67 is symmetric matrix. It's symmetric matrix. See here, consider this matrix here. Binary symmetric matrix. We call this one as symmetric. Why? In first row, what are the elements here? P bar and P. In second row also, same elements in different order. Right? P and P bar. P here, yes, P bar here. Okay, that's why I call it as symmetric matrix. Hence, the channel is a symmetric channel. But for a symmetric uniform channel, the equivocation is given by h of y divided by x is equal to h. Wait a minute. So we already put this one. Here we know that what is h of y divided by x is equal to h. That is equal to I equal to 1 to 2 symbol pj log of 1 divided by pj. See here. Where we put this one? Here. It's symmetric, right? Then what is h of b divided by a? H of b divided by a. B is output, a is input, right? Here x is input, y is output. That's why h of y divided by x is equal to h. H is equal to how many symbols here? 2 symbols. That's why I equal to 1 to 2 pj log of 1 divided by pj. Okay. Here expand this one. P1 log of 1 divided by P1 plus P log of 1 divided by P. Okay. Here the P1 is P bar. P bar 1 divided by P bar. P log of 1 divided by P. Okay. Now we can find the h of y. How we can find the h of y? Here we know that h of y is equal to entropy, output entropy, entropy of the output symbol. H of y is equal to j equal to 1 to 2 p of yj log of 1 divided by p of yj. Okay, the probability values here you can write. Here you can write the probability value. P of y1 log of 1 divided by p of y1 plus p of y2 log of 1 divided by p of y2. What is the probability of p of y1? Here, p of y1 and y2 are found using the theorem of total probability. We already discussed this one. how we can find, already discussed this, what is the theorem of total probability. Okay, how we can find the output probability here using the channel matrix. See, P of y1, P of y1 is equal to P of y1 divided by x1, P of x1 plus P of y1 divided by x2, P of x2. What is P of y1 divided by x1? It's P bar, right? P of y1 divided by x1 is P bar. You have to go through these equations, already solved. Okay, P of y1 divided by x1, P of x1 plus P of y1 divided by x2, P of x2. Okay, then P of y1 divided by x1 is, refer the matrix channel here. Y1 divided by x1 is P bar, right? Right, P bar. Then P of x1, the input symbol probability is W. Then P of y1 divided by x2, okay, P. P of x2 is W bar. Similarly, P of y2, P of y2 divided by x1 multiplied with P of x1 plus P of y2 divided by x2. Here, just remember, you can change it. P of, it was missed here. P of x2. Okay, then here, this is equal to, this value is P from the, by referring the channel matrix. Okay, this value is W, this value is P bar, and this value is W bar. Now, H of y becomes, now H of y becomes, substitute P of y1 and P of y2. P of y1 and P of y2. We already, there are the equation for P of 1 and P of y2 using theorem of total probability. Okay, then here you can write, I will substitute these values in H of y equation. Here P bar W plus PW bar, substitute here. P bar W plus PW bar, log of 1 divided by P bar W plus PW bar, plus PW plus P bar W bar, log of 1 divided by PW plus P bar W bar. Here we are discussing about the capacity. What is the capacity? Capacity is maximum of I of AB or BA. So I will take I of y comma x, mutual inductor, mutual information. What is mutual information? I of y comma x is equal to I of xy, that is equal to H of y minus H of y divided by x. Here we know these values. That's why I have taken H of y comma x. If you take an I of xy means H of x minus H of x divided by y. Okay, here both are equal, that's why I written I of x comma y is equal to P bar W plus PW bar H of y from this equation number 3.70. Log of 1 divided by P bar W plus PW bar plus substitute PW plus P bar W bar, log of 1 divided by PW plus P bar W. Then substitute P of y divided by x using which equation? 3.69. The minus of P bar log of 1 divided by P bar plus P of log of 1 divided by P. Okay, by using equation 3.68 and 3. Okay, since BAC is a symmetric channel, the channel capacity with RS equal to 1 message symbol per second is found by using 3.6. Already we know that we proved this one. We proved already this one. Yeah, log of, yes, see, because that means here binary symmetric symbol is what? Binary symmetric symbol is, it's a symmetric informed channel. This one, symmetric informed channel. That's why its capacity is what? Log of S minus H. Okay, what is S? Total number of the outputs. How many number of the outputs here? What is the value? 2, right? Then log of 2 minus H. What is the value of log of 2? What is the value of log of 2? It's 1, right? 1, right? Then 1 minus H. Then substitute here. C is equal to 1 minus of, there P value is different here. Sorry, H value is different. H is equal to J equal to 1 to S Pj log of 1 divided by Pj. But here, in terms of P bar and P, H value is P bar log of 1 divided by P bar plus P of log of 1 divided by bits per second. Okay. Now, it is interesting to note that when W bar equal to 1 divided by 2, W bar equal to 1 divided by 2, where the W equal to, where here W and W bar equal to 1 divided by 2, he mentioned here, wait, 1 divided by 2, then equation 3.70 becomes, you substitute W value here, where here only, right, 1 divided by 2, okay, here also 1 divided by 2. What will happen here? 1 divided by 2, 1 divided by 2, I will take 1 divided by 2 common here, okay, W is 1 divided by 2, W bar is also 1 divided by 2, that's why I will take 1 divided by 2 common, it becomes P plus P bar log of 1 divided by, again here I will take W and W bar 1 divided by 1 divided by 2, I will take outside here 1 divided by 2, here 1 divided by 2, here also same, okay. We know that what is the value of P plus P bar? P equal to, P bar equal to 1 minus P, right, then P plus P bar equal to 1, that's why P plus P bar equal to 1, substitute here, P plus 1 minus P, that is equal to 1, this P cancel, both are 1 right here, that means here P plus P bar equal to 1, P plus P bar equal to 1, how? Here you can substitute P bar value, it's equal to 1 minus P, then this P cancel, what is P plus P bar? It's equal to 1, right? Yes, and proved. Then substitute 1 here, 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 and here. Then it becomes 1 divided by 2 log of 2 plus 1 divided by 2 log of 2. And the I of xy becomes, what is I of xy? It's equal to, say here, I of xy equal to h of y minus h of y divided by x. What is the value of h of y? It's 1 minus h, 1 minus h of y divided by x, this one. That is also same. That is also same as here. I of xy equal to 1 minus h. Here, hence, equation 3.73 and 74 are identical. We can conclude that when the input symbols become equiprobable, the mutual information maximizes and becomes equal to channel capacity. Okay, here we know that here we get the capacitance, sorry, capacity. What is capacity here? C is equal to 1 minus h. What is h? H is this term. H is this term. Okay, H is this term. Now, what I will do here, the probability of what symbol? X1 coded at 0, its probability is W, right? Its probability is W. Okay, second symbol X2, its probability is W bar and it's coded as 1. Okay, now both W and W bar equal to 1 and that means equiprobable. Okay, so here equation 3.73 and 3.74 are identical. Therefore, we can conclude that when the input symbols are equiprobable, mutual information, that means I of xy equal to C. What is C here? Capacity. I of xy is mutual information. Let's go through this. This is the channel diagram. X1 and X2 are inputs, Y1 and Y2 are the outputs. Y1 receives 0 value, Y2 receives 1 value. is a x1 input transmit 0, x2 transmit 1. x1 probability is W, x2 probability is W bar. Okay, h of y1 divided by x1, sorry, p of y1 divided by x1 is p bar is equal to 1 minus p. Just remember. Okay, p of y2 divided by x1, what is p? P is called as here probability of error. When input is 0, what will receive a 1? Here, probability of reception of 1 when 0 is transmitted. Similarly, here also P. Okay, probability of reception of 0 when input is 1. Just remember this. Okay, here write the channel matrix. Okay, how we can write the channel matrix? Channel matrix would consist of what? Conditional probability, right? Yes, this is a conditional probability. Already we know these values p bar, p bar. Okay, then here h of y divided by x is equal to h of y divided by x is equal to summation of I equal to 1 to 2 pj log of 1 divided by pj. Okay, p1 log of 1 divided by p1 plus p2 log of 1 divided by p2. Write the condition probability. Okay, p bar and log of 1 divided by p bar plus p log of 1 divided by p. That is h here. That is h. Similarly, to find h of y, we can use the theorem of total probability. Okay, h of y is equal to this one. Summation of j equal to 1 to 2 p of yj log of 1 divided by p of yj. P of y1 is equal to, sorry, p of y1 log of 1 divided by p of y1 plus p of y2 log of 1 divided by p of y2. So how we can find the output probabilities using condition probability, this equation. Just remember this equation, it's very, very important. This equation and this equation. Okay, substitute that p of x1 values and condition probability values, we get h of y, this one. Okay, this is I of xy. I of xy is equal to this one. Okay, then we know that the condition capacity is equal to log of s minus h. Why it's log of s minus h? We already put in the uniform channel, symmetric channel. Its capacity is log of s minus h. Here, this binary symmetric channel also symmetric, because in first row, whatever in first row of the channel matrix, whatever the elements are there, those elements in the second row also in different order. Okay, then C is equal to, yeah, how many output symbols here? Yes, yes, the number of output symbols is 2 minus h, 1 minus h. C is equal to 1 minus of this one, h value. I'll be taken here. Okay, now we can substitute W and W bar equal to 1 divided by 2 in equation 3.70. We get I of xy is equal to 1 minus h. This equation same as equation 3.73. That's why, okay, when the probabilities of the inputs are equiprobable, the mutual information is equal to capacity. Okay, this is about the binary symmetric channel. Please go through this. Is it audible? Anyone can reply?